We're back with 12.3. It's encompassing the prism and pyramid idea, but instead of having bases that are polygons, the base is a circle. So the concepts are the same though. So we have cylinders and cones. Cylinder is like the prism, right? Except it has bases as circles, and cones are like pyramids, except bases for a cone is a circle. So right here it says a cylinder is like a prism except its bases are circles instead of polygons. Wow, I'm like a broken record. I could just keep saying it and saying it. The bases are circles. A cylinder has bases that are circles. A cylinder has bases that are circles. Hey, did you know that a cylinder has two bases and they're circles? That's pretty cool. Like, for example, a soda can. Some of you might be familiar with the soda can, right? It looks like this. Well, if you were to unravel that soda can, say you got out scissors or something that cuts aluminum and you cut the top off and you cut the top off or the bottom off, then you would have the top here and the bottom here if we laid them flat, and you unwound this part right here, what would happen? It would become a rectangle, right? That would become a rectangle where the height of the rectangle, right, is this vertical altitude. That's this part right here. But then the circumference around here, we just unwound that and it became this part. So my length across the bottom is the circumference of the base. So think about that. So if I'm trying to, so what is the shape of the lateral area of the cylinder? It's a rectangle. Except how would you find the area? Well, it's the height, right? We said this part's the height of the can itself. But the length, we just said, is the circumference of the base. And what is the formula for circumference? The formula for circumference is 2 pi r, where the radius, we're talking about the radius of the base. Right, so this is the radius of the base. So lateral area of a circle, 2 pi r times height of the circle. Volume of the cylinder, well, that's the same as anything else. It's going to be the area of the base times height. But if you want to be more specific, the area of a base, well, it's a circle. So more specifically, it's pi r squared h. Now what would the surface area of a cylinder be? Well, that would be the lateral area plus, right, so the surface area, which I didn't put in here for some reason, kind of silly of me. The surface area, SA, surface area, of a cylinder would be your lateral area, which is the rectangle, plus 2 bases, so that's 2 circles, the top and the bottom. So that's why I multiplied 2 times pi r squared, and there's my 2 bases. So this is my surface area for a cylinder. Okay, now a cone is just like a prism, or a cone is like a pyramid. So what do you think is going to happen to the volume of the cone? Well, we're going to divide it by 3. So what do? Volume of cone, it's 1/3 of the base times the height. But what is the base in this case? It's pi r squared. So it's pi r squared h divided by 3. Right? The base times height divided by 3. What shape is the lateral area of a cone? Okay, that's tricky. And if you were to do the next activity that we would typically do in class, so if you want some visuals, I can help you in class. So if you took this part, so think about it. Have you ever drank in one of those little paper cups that looks like a cone? Well, if you took that paper cup apart, what shape would that be? And actually what it would be is it would look like kind of like a fan. Or more specifically, what shape is this? Many of you forgot that on your test. It's like the shape of a piece of pie, which is called a sector. That is the sector of a circle. So it's just a part of the entire circle, area of a circle. So what shape is the lateral area of a cone? It is a sector, which is like a piece of pie, or I was thinking kind of like a fan when you fold out a fan and you fan yourself to cool yourself off. It's kind of like that too. How would you find the area of that shape? Ooh, that's a good question. So how do we find the area of this sector? Okay, well we learned last chapter, the way you find the area of a sector is by taking this angle here, whatever that may be, and divide that by 360 degrees and multiply that by pi r squared. But in this case now our r squared, or our r, is actually the slant height of the cone, which is here. Now the big question is, why does it then say, sorry, this shouldn't say surface area, this should say the lateral area. So lateral area meaning just this shape right here of the sector. So the lateral area of a cone, the formula they give in the book is just pi r l. So it's the radius, but the radius is referring to this radius of the base of the cone, times L, which is the slant height of the original shape of the cone. So how does this pi r l translate equal theta over 360 times pi r squared? That's the million-dollar question, and I want you to think about that, and then we can talk about it in class. Maybe we'll do this activity down here. I'll cut out the sector and we can look at it so you can see just why that really does work. So for now though, this is probably the easier one to remember or to memorize to help you find the surface area of a cone. Volume of a cone, as we already said, it's going to be 1/3 base times height, right? So that's pi r squared is our base because it's a circle. We're going to multiply by the height and then divide it by 3, and there we have our volume. Okay, what I think you should do now is pause and go ahead and solve these problems, and then you can check them when you're done and see how you did. Okay, if you notice here, you can't do these problems. It says calculate the surface area and volume of your cone. Well, that was only if you did the activity from the front of the page. So if you did that at home, great, you could find the volume and area of your cone and cylinder. However, if you didn't, I can just make up some measurements in class and we can practice then. And instead, you can just jump down to these bottom ones. So if you haven't done the bottom ones, you should push pause and try again. But if you have, then go ahead and check your answers here. So it says a cone with radius 6 centimeters and height 12 centimeters is filled to the capacity with liquid. Actually, so this is upside down, because you wouldn't fill it looking like that. Or we could if we poured it in the top. Find the minimum height of a cylinder with radius 4 centimeters. So notice that radius is smaller. So we have a smaller base here, which means our height is going to be taller, right? It's going to be taller than this. Or is it, I guess? So we should figure this out. So a radius of 4 centimeters, that will hold the same amount of liquid. So first we need to calculate how much liquid we have. So that is pi times 6 squared times 12. So remember it's pi r squared h divided by 3, which is 144 pi. So that needs to equal, look at that, I caught my error. So that needs to equal the other volume. So the other volume needs to be pi times 14r squared divided by 3. So I forgot to divide by 3 because I was thinking to myself, why would the height be smaller than this one if I made my base smaller? Anyway, so what do? We have 4 squared times pi, which is 16 pi, so I can divide each side by 16 pi. So I get 16, the pi's cancel. 144 divided by 16, we get 9. So 9 equals h divided by 3 now. Right, so these cancel like this, the pi's cancel. 144 divided by 16 is 9, but now we have to get rid of our 3 by multiplying by 3. So what would the height of the new cylinder, or sorry, the new cone have to be? It would have to be 27 meters. Obviously going to have to be taller than the original because we shortened our base radius, which means if we're putting in the same volume, it's going to have to be a taller cone. And the second one, it says a right cone, so here's my right cone, and a right cylinder have equal base areas. The height of the cylinder is 4 times the height of the cone. So I tried to make my cylinder 4 times taller than the cone. Right, so that means we don't know the height though. So I just put an x. If the height of the cone is x, and the height of the cylinder is 4x. If the height of the cone is 2, then the height of the cylinder is 4 times 2, which is 8. Right? So you can do numerical values, or you can just put it in your x. So finding the volume of the cylinder, well, that's pi times r squared times 4x. The height is 4x, the radius is r. Again, it's an unknown. But what do we know? We know that the radius of the cone and the radius of the cylinder are the same value. So here's my volume for the cylinder. My volume for the cone is pi r squared times x, just x by itself, not 4x, because it's 1/4 the height of the cylinder. But we have to divide that by 3. So it says compare their volumes. When we compare their volumes, we usually get a ratio. We want to compare how much bigger is the cylinder's volume than the cone's volume. So if you took this volume, which would be 4x pi r squared, and we did the ratio to the cone's volume, which is pi r squared x divided by 3, we can start canceling like terms. So pi r squared, or pi and pi cancels, r squared and r squared cancel, x and x cancels. So we have 4 divided by 1/3. So if you do 4 divided by 1/3, that's the same as 4 times 3 over 1. So the ratio is really 12 to 1. That means the cylinder is 12 times bigger than the cone. So it can hold 12 times more volume. And how did I figure that out? I just simply did a ratio to figure it out. So again, ask me questions in class. We'll do more practice problems in the book and see how it goes. Hopefully, though, it just kind of blends in with the prisms and pyramids, except now our bases are circles. So hopefully it won't be a problem based on everything you've learned in the past. I will see you soon.